All right. So for today, I thought we could just do a little bit like a demonstration, a demo of some exploratory data analysis in Python using pandas and Seaborn, and just um, kind of get get through uh, this exploration of the data. Okay, so the data we're going to take a look at today comes from the National Health and Nutrition Examination Survey. This is a survey conducted by the CDC, and you can learn all about it. Let me see if I can open this link here. So, so this they have all kinds of stuff. It's actually a pretty fascinating data set if you have the time to go through it. I'm going to load up a data set from a few years back, but it's all kind of very similar. The data dictionaries are very thorough, so let me open these up. Okay, and there's several tables part of the data set, and we are going to look at. Oh, actually, I guess these links are outdated. I have to update them. So within the codebook, we have the examination data. There's dietary data, demographics data, examination data, lab data, things like that. So we're going to look at the demographics data and the examination data in today's table. So let me see. All right, sorry, I need to update the links for the codebook here. What is it? It's going to look like this. Body measures. So to get to the codebook, we're looking at the NHANES 2015-2016 data. And then the links up here are all part of data, documentation, and codebooks. So, as far as the examination data, I'm going to click that. And then they have all of the different exams. And we're going to look at the body measurements table, BMXI, okay, for body measures. And this is where they measure things like, where is it? Things like someone's weight, okay? Recumbent length is how long they are if they're lying down. Head circumference, standing height, BMI, upper leg length, upper arm length. So they're just kind of taking measurements of all of these different body parts, okay? And it's kind of interesting, the information in there. All right. So anyway, sorry, the links I've provided in the original notebook are outdated. Okay, but anyway, we'll go ahead and I've downloaded the tables as well. So if you want to get the table themselves, so you have the link to the documentation, and then you have the data file. Okay, the data file comes in as an XPT, which is a SAS document or a SAS data file. So anyway, we'll go ahead and load up our data. So we're gonna load our libraries: Pandas, NumPy, Matplotlib, and Seaborn. And it's taking my computer a little while to get those libraries loaded. And then, well, anyway, as soon as that's done loading, we'll load the data files. Okay. I think I've put the data files in the repository. So if you do a git pull upstream main, the BMX body measurements table and the demographics table should both be in in your data set. Okay, so as far as these tables go, let me just kind of show you what the table looks like. So this is, sorry. Okay, so this is the body measurements table. We have a sequence number, and then we have a whole bunch of different values for things like the weight and the head height and the, I don't know, upper arm length and things like that. Okay, and then we also have a demographics table, which I'll do right here. Okay, and so each individual is identified with a sequence number. All right, and so we can merge our two tables together by merging them on the sequence number. Okay, and so this the demographics thing has things like gender and age. I don't know, different kinds of stuff here. All right. Anyway, so I'm going to merge these together, and we're going to do body measurements dot merge, okay, to demo, where the right table is demo, and then we're going to say merge them on the sequence number, and therefore our merged table looks like this: 9,544 rows and 72 columns. I can ask for information, and it tells us, like, all right, we got 9,544 values, and as far as different numbers go, we have, you know, some things are missing, but we have a lot of values for a lot of things. Okay, so we have head measurements and things like that. And so, you know, as far as the demographics table, we have things like, so, you know, you need the data dictionary to tell you, because, you know, for example, gender is coded as a 1 or a 2, and you need to know what 1 represents and what 2 represents. So here 1 represents male and 2 represents female, versus, you know, if you did alphabetical order, 1 would be female and 2 would be male. So the data dictionaries are very important and things like that. You also note things like age in years actually only goes 0 through 79, okay, and then 80 or higher just gets put down as 80 in the data. So that's you know, something to keep in mind. Okay, so if you wanted to find out, like, oh, what's the average age, you know, or what's this for people over 90, that's not possible, not with this data set. Okay, and things for, you know, as far as race and you know, served in the military, stuff like that. Okay, country of birth. So anyway, so I just decided to ask a few kind of arbitrary questions, and then I wanted to try to go through as far as detecting, or trying to look at our data to answer these questions. And I apologize, I didn't check these links, and so these links are all going to be outdated. So you'd have to go find the updated data dictionary links for each of these things. Okay. So the variable for age in months is RID, age, MN for months. For gender, it's RIA gender. Okay, and then for the variable for weight is BMX WT. Okay, and so the question is, do baby boys weigh more than baby girls on average? And so, so I thought this was kind of interesting. So what I want to do is I want to take our merged table, and we're going to look at all babies, and I'm going to just arbitrarily look at babies for as having ages in months 0 to 12. Okay, so under one year of age, we're going to look at the column RID age MN, and we're going to say less than or equal to 12. And then so using the .loc, I'm going to use this as kind of a way to filter down to those rows. Okay, so we're going to filter to these rows. We want to select all of the those columns. Okay, and then I'm going to do a dot copy because I believe it's going to be a view if I don't. So I'll go ahead and do that. And just to kind of check, we're going to see we have a total of 399 babies in our data set. Okay, and then if we look at this, if I do babies.info, okay, we're going to see that here actually. Let me select loc. We want to pick the column for age in months, RID age MN. Okay, so what we see is that all of these things are they're technically floats, and then just to kind of make it a little bit easier for us to work with, I'm going to just rename the column as far as age goes. Okay, so actually I'm not going to rename it. I'm going to just create a new column called age, and I'm going to just take this and then I'm going to convert it to an integer type as type int. Okay, so that's going to create a new column called age, and then here I'm going to subset to boys, and we're going to do I'm going to call this baby boys, and then so we're going to do babies, and then we're going to do a dot loc, and we're going to set it to where if gender is equal to 1, that's going to be the baby boys. Inside of 399 babies, 192 are boys. Okay, and then I'm going to form groups by age. We're going to select the column weight, and then we're going to calculate the mean. Okay, so this is going to be the mean weight of boys for each month. Okay, so age 0 months, 1 month, 2 months, 3 months. This is what we see. Okay, and then we'll do the same thing for girls. Okay, so I'm going to set gender equal to 2, and we'll filter down to those using .loc. And then we have 207 girls, and then again I'm going to do a .group by. We'll select the BMX weight, calculate the mean weight there, and we have this. Okay, so I have the table, the series for age in months for baby boys, and I have the series for age in a series of weights by age in months for the girls, and then we can calculate the difference between the boys' average age and the girls' average age. Okay, and so if I plot the difference, what we see is that there's actually every month there's a positive difference. If I do the boys' average age minus the girls' average age, that difference is positive. So that just means kind of consistently month over month, the boys tend to weigh more than the girls. Okay, there was no month where the average weight of girls was higher than the average weight of boys. Okay, anyway, maybe we want to create a plot. Okay, so what I'm going to do is I'm going to combine the two series together into a single data frame. And so to do this, I'm going to create a data frame. I'm going to do pandas.dataframe, and then I provide a dictionary, basically the column name along with each series. And so if I do this, month weights will look like this, and now I have a data frame. Basically, I've taken the boy values and the girl values, put them down as far as ages go. Okay. And then we'll take the index. I think right now, let me just check. So yeah, the index is an int, but I guess I'm just gonna make sure the index is an int, and then we'll call plot. Okay, and so here's a plot comparing the average age of girls and boys, and we can see just kind of consistently each month the mean weight of baby boys is greater than the mean weight of baby girls. It kind of goes up and down because again each month it's just a random selection, and so it just so happens that the 10-month babies happens to weigh more on average than the 11-month babies. Okay, but overall we see kind of this consistent trend of as older babies tend to weigh more than younger babies. Okay, and then we also, interestingly enough, baby boys tend to weigh more than baby girls, at least in our data set. And if we did a statistical test, we'd probably find this difference to be significant. Which I thought was interesting as far as the average weight of boys and girls. Okay. Here, let me give you your first view quiz answer. It's Friday already. Okay. Letter C. C as in cat. C as in cat is your first view quiz answer. Okay. Another relationship I want to look at is what's the relationship between height, leg length, and arm length? And does this relationship change with age? Kind of the general wisdom regarding someone's height is that as they get older, they get taller, at least from childhood until they reach adolescence. And then somewhere around there, people stop growing and then they maintain kind of the same height. And then in the later years, they start to get shorter. Okay. And so I just thought, okay, well, maybe we can just look at some of these variables. We'll look at the age in years, people's height, their leg length, and their arm length. And I've arbitrarily decided, okay, let's look at people over age 20. Okay, so just kind of assuming people have reached adulthood, and just look at how these things are related. So we'll have the overall height, and then leg length and arm length. And so anyway, I've just arbitrarily called this the subset limbs, where I'm going to select these variables: height, leg length, arm length, age. We're going to create a copy. We'll drop any of these missing values. And let me just go ahead and print the top part of that data frame. Okay, so we have 7,100 rows. And then what I'm going to do is I'm going to filter to where age is over 20. Okay, so we can see, here's an individual whose age is only 8. And then if I do that, then, that filters down to, only around 5,000 entries, but I think it's still kind of interesting as far as the values that we have. All right. Now we can just start by looking at, is there a correlation between height, leg length, and arm length and things like that? And generally, we assume there's correlation, right? In general, taller people have longer arms. Okay, taller people have longer legs, but it's not like a direct thing. And so you have some people that happen to have unusually long arms or comparatively short legs. So, if we think about certain athletes, there's a basketball player, Kawhi Leonard. He's tall, but he also has really long arms for his height, okay, which makes him a very dangerous defensive threat because he can steal your ball and stuff like that. I think Michael Phelps, Olympic swimmer, and has won super number of gold medals and stuff. Relative to his height, he has shorter legs, okay, which I don't know, I guess help as far as swimming. I don't know the mechanics of it, but he has long feet, but his legs, I think, are relatively short compared to his stature. I'm not sure. I think I think I remember seeing something like that. You know, it's like certain body parts. You know, um, but anyway, so we can just do like a correlation. You'll get like this big correlation table. Okay, so you can just take you can just select numeric variables and call dot core. Okay, so here I'm just subsetting to just these numeric values, and I'm calling dot core to get correlation, and we get positive correlation. Height and leg length has a correlation of around 0.79. Height and arm length has a correlation of around 0.8. Okay, and then the one with the least amount of correlation is leg length and arm length, with a correlation of only around 0.63. But anyway, that's what we have. Okay. Now, as far as if I could try to do like group by age and calculate the mean. Okay, but if I did that, let me just show you what would happen if I did adults.group by age, which what is, I forget, it's rid age year. Okay, if I do that and then I say, all right, let's select BMX height or something like that, and then let's do the mean. You'll see we're going to get a mean for everybody who's 20, everybody who's 21, 22, 23, and just because I don't know how many people we have in our data set that's exactly age 20, age 21, age 22, you get like a lot of variation, right? Just because if there's only like 5 people in each of these age groups, the amount of variation could vary quite a bit. So instead, I want to create like bins, and we'll say everybody in their 20s, everybody in their 30s, everybody in their 40s, so on and so forth. Okay, so the function we can use here is called cut. Okay, so we have pandas.cut, and you can create bins based on ranges. So here I'm going to create a age groups. Okay, I'm going to take adults in the ages. Okay, and then I'm going to say the bins I want to create are going to go from 20 to 99. Okay, in groups of 10. Right equals false. And so what this will do is basically our bins will go 20 to 30, 30 to 40, 40 to 50, 50 to 60, 60 to 70, 70 to 80, and 80 to 90. Okay, so right equals false means basically the 20 to 30 goes 20 to 29.9. There's ages are just whole numbers, so basically 20 to 29, and this would be 70 to 79, and then the last one is 80 to 89, but again in our data set it's just 80 and everybody older than 80. So I think that works as far as this goes. Okay, so so I'm going to create a new column called age_category, or age cat, and we'll take the age groups there. Okay, and so now our data set looks like this, and we can see, oh yeah, indeed, this person who's 62 goes into age category 60 to 70, 53 is in that category, and so on and so forth. Okay. Okay, and then so now I'm going to do group by the age category, and then we'll calculate the mean, and we'll do it for, we're going to get it for each of the variables here. Okay, so I'm going to get the mean for height, mean for leg length, mean for arm length. Okay, and just so that we can kind of print this, as far as the indexes go here, I'm going to just replace the index, so I don't have 20 to 30, 30 to 40. I'm just going to put 20, 30, 40, so on and so forth. Okay, so I'm just replacing the index here with just kind of like, just think of this as 20s, 30s, 40s. Okay, and so now I can create a plot. Okay, and this is what my plot looks like. Now, unfortunately, because height is so much higher than everything else, when it gets plotted, it's actually really hard to see any kind of relationship, okay? So I'm going to just arbitrarily, I'm looking at this and I'm like, okay, 167, 40, 166, 38, so on and so forth. I'm going to just arbitrarily subtract around 128, okay? And that's the hope to kind of get everything on this on a similar scale. So I'm going to just create a new column that's just going to say, hey, take the height values here from our summary table, subtract 128, and all this is going to do is just going to basically recenter. I mean, I could have also just subtracted the mean off of everybody, but just arbitrarily I picked 128, okay? And this is the resulting plot, okay? Which I thought was kind of interesting, all right? So as the ages go on, and again, I don't know if this is a causal relationship or if this is like reflective of nutritional trends or whatever, I don't know. But the average leg length of people in their 20s is longer than the average leg length of people in their 30s, longer than the average leg length of people in their 40s, and so on and so forth. And then you see height and leg length kind of are parallel all the way through here. And then for people over 80 and over, there's kind of suddenly a departure between average leg length and height. Okay, now there's kind of a drop. But I don't know, does that mean like our legs shrink as we get older, or is this like nutritional differences? I don't know. I have no idea. Interestingly enough, as far as arm length goes, that like stays constant through. This seems relatively flat. So I don't know. I've never measured my leg length, so I don't know if like my own legs are shrinking. Like, are my legs today shorter than they were, like a full centimeter shorter than they were when I was in my 20s? I have no idea. That's anyway, just kind of a interesting thing. Let me go ahead and give you your second view quiz answer, which is the letter B. Okay, the letter B. Okay, and all right. What about, is there a relationship between height or weight and income? And this is like, you would think there should be no relationship, but then when you look at the data, that like somehow there does appear to be some relationships, and I don't know what the cause is behind all of these things. More money to spend on food. Yeah, so yeah, well, yeah, but then also, what about height? How do we explain that? And so I don't know. Anyway, so as far as the data that we're gonna, the variables we're gonna select height, weight, and then in the demographics table, so we have age, and then the IND, I think this is the income. Let me see. This is IND, household income in dollar ranges. Where is it? Okay, annual household income. This is the variable, and so unfortunately, as far as the code or the value goes, there's like two different scales that they used. Okay, so they have like 0 through 5,000, 5,000 through 10,000, 65 to 75,000 for one thing. And then they have another, a secondary scale, 20,000 and over, under 20,000. And then they have a 75,000 to 100,000, and then 100,000 and over. So I think I said we're going to get rid of, as far as these different values that we're going to take, I'm going to get rid of categories 12 and 13, just because this makes it a little bit hard to work with. Okay, so at least now I kind of have this sort of continuous range going from 0 to 75, 75 to 100 and 100,000 and over. And then we'll get rid of everybody who didn't respond or their values are missing. And then we're also going to get rid of categories 12 and 13, where they only kind of said, I'm over or under 20,000. So anyway, we'll select those columns. We'll get rid of anybody with missing values, and then select just adults, okay? And then we can kind of form groups based on the mean, but again, we're going to get rid of categories 12, 13, and then categories 77 and 99, which are basically the refused or missings, refused or don't knows, okay? So as far as selecting these things, okay, these are the mean values. So there's kind of a lot here. We're going to filter to the rows where I just specify the indexes that I want, okay? And unfortunately, with pandas in Python, you have to kind of nest all of these things in each other, okay? This is kind of like dealing with data frames in R prior to the tidyverse. So we're going to say, all right, this is the data frame. We're going to select the index, okay? And then do is_in means it's going to be one of these things. We're going to subset to those rows. We will look at BMX weight, and then we'll plot this, okay? So as far as this goes, I'm going to create a plot here. And so, yeah, it's hard to fully draw, but we see as far as average weight goes, there's kind of it goes up and down, but just in general, maybe positive trend. So perhaps, yeah, people with very low household incomes maybe struggle with food security, and so weight tends to be lower. But then kind of, I don't know, higher and lower, it's hard to know exactly what's going on there. But so that, again, what's the explanation behind all of this? I don't know. But then interestingly enough, if you look at height, there is, a very kind of positive trend. And so again, I don't know. As far as having income associated, with kind of nutrition and food security, it does kind of make sense. But then, I don't know, what's the relation? How do you explain the relationship with height and income? And that is, I don't know. I don't know if there's a directional cause, if there's confounding variables, but I do think this is actually if you look at data, not just in the U.S., but I think this trend does exist, and I don't know if this just means there's bias against tall or short people or something. I don't know. I don't know what the. It could also be. I wonder. Well, you know what? Now that I'm wondering. See, I don't know. It's household. I wonder if it's gender biases. So if women tend to earn less, okay, then if that's I don't know. It could be just revealing. So again, we have to, as far as drawing conclusions, we have to be careful about making any kind of cause and effect things, but and being aware of certain kind of biases and things that exist in society will be reflected in the data. And so anyway, this was just I was just kind of fiddling around with the data and just exploring things. So now that I have this, I wonder if if I go back, did I select? I didn't select gender here, huh? So if I go back and mess with this, so let's select, what was gender is RIA gender. Okay. Let's try this. RIA gender. All right, so we're going to do income, weight, and gender. And so I'm going to just kind of see if we can figure this out here. Okay, so I have that. So just kind of printing this. Okay, and then if I form groups, all right, we have the income values. Let's group by index and gender. Let's see if we can form a multi. Okay. It doesn't like that. Oh. Spelling wrong. Okay, so we have this and that. All right, so let's try selecting that. Can we plot this? Oh, okay. How do I need to, okay, I have this. Let's call unstack. Okay, and then we'll call plot. So we definitely do see a difference, but there's still, it does look like there's a positive association. So hard to know. So this goes from 163 to 168. Yeah, 170 to 175. Yeah, still kind of a 5 centimeter difference between the lowest income group and the highest income group. There's still kind of a 5 centimeter difference. We definitely do see a difference in terms of heights for, I mean, so as far as heights for the different genders, this is what we see. But yeah, interestingly enough, as far as household income, there is also a 5 centimeter difference from the lower to the higher end. Okay. Anyway, this is kind of all I have prepared for today regarding just some exploratory data analysis. We've covered kind of a lot in terms of stuff you can do in Python, and I'll assign a homework that kind of forces you to do a little bit of exploratory data analysis. But truly the best way you're going to learn and solidify your skills, I would say find a data set that's interesting to you and ask questions and see if you can get the answers yourselves by kind of exploring it in Python, and just kind of force yourself to use Python to do this data exploration. That's really going to be the best way to learn. I say find a data set that's interesting to you, because if it's interesting to you, you will have interesting questions to ask that you'll want to that you'll be motivated to kind of find the answers to. You know, if you take a data set that is of very little interest to you, you'll try a couple exercises, get tired and bored, and then you'll quit. But if it's something interesting to you, then you will naturally kind of have questions and curiosities, and that will provide, I'm hoping, the motivation to to try to seek out those answers. Okay, let me give you a last view quiz answer for today, which is the letter A. A as in apple. A as in apple. Okay, we'll end there. Have a good weekend, and we'll see you next week.